Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's biweekly contest, maximum subsequence score. The problem states that you are given two arrays nums1 and nums2, both are of size n, and you are also given a positive integer k. Now you need to select a subsequence of indices from nums1 of length k, right? So you will select, let's say, I0, I1 up to ik minus 1. So this is a subsequence that you selected which is of length k. Now the score of this chosen subsequence is defined as this. So you take the sum of all the elements in the subsequences from nums1 and minimum of all the elements chosen in the subsequences from nums2 and multiply them. So this is the score of a chosen subsequence I0, I1 up to ik minus 1. Now you need to return the maximum possible score. So this is a score of one subsequence. You will try out every possible subsequence and just return what is the maximum possible value that you will get, right? Now let's take an example. Let's say this is nums1 and this is nums2 and k is 3, right? So there are, like, you have to select a subsequence of length 3, right? So there are four subsequences possible. First subsequence which consists of 0, 1 and 2, right? Then there is second subsequence which consists of 0, 1 and 3, and 0, 2 and 3, and 1, 2, 3, right? So the score of this subsequence 0, 1 and 2 is defined as sum of the elements or the chosen subsequences in the nums1, right? 1 plus 3 plus 3, and minimum of the elements chosen in nums2, which is minimum of 2, 1 and 3, which is 1. So 1 into 1 plus 3 plus 3, which is 7, and hence the score of this subsequence 0, 1, 2 is 7. Similarly, we find out the score of every possible subsequences, right? 7, 6, 12, and 8. Now 12 is the maximum possible score that we are getting, and hence we return 12 as an answer, right? So hope the problem statement is clear. Now how to solve this? So notice that this is the score, right? And you have to select these subsequence of length k, right? Now how many subsequences of length k are possible? There are total n elements, right? And you have to choose k elements from that, right? So these many number of subsequences are possible. And for each of these subsequence, you will find out the score. So to find out the score, you need to iterate over the array, right, of length k. So the to find the score, you will require order k time. So this is the final complexity if you just solve it in a brute force manner, right? So even finding out subsequences of finding out subsequences of length k in itself is a good problem to solve if you are not well versed with recursion. This is one of the good problem to solve as well. So I would encourage you to solve this. But getting back to the solution, like, this will not work because the value of n here is 10 to the power 5 and k is also 10 to the power 5, right? So you can see this n choose k would, like, is in the order of n factorial, right? So it will not work for sure. So we need to optimize it by a lot of factor. So notice that n choose k, we can't actually use this term at all in our time complexity, right? Because this term itself is very huge. So we need to come up with something where we don't iterate over all the subsequences, because removing n choose k from the complexity means that you are not iterating over all the subsequences, right? So we need to come up with something which will give us the answer even if we don't iterate over all the subsequences. So here now it becomes an optimization problem. Like, you need to come up with some trick or some observation that will help you not iterate over all subsequences but still get the optimal answer, here the maximum score. So now coming to observation, so very first observation that you can make here is, like, this is sum, right? So you can't have like, you can't do much here. This is minimum, so this is an interesting operation. Now why it is interesting? Notice that you are doing a minimum over some elements of nums2, right? So what would be the answer, or what would be the result of this minimum? The result of this minimum is one of these elements, right, which you have chosen. So let's say you are taking minimum of 2, 1 and 3. So the minimum would be 1, right? So minimum is one of the elements that is already present here. So minimum of this will be something nums of ij, right? Minimum of this entire sequences of elements is nums of ij, nums2 of ij. So we see here that how many distinct value of nums of 2 ij is possible? Only n, right? Because there are n elements in nums2. So because only n distinct value of this is possible, why not iterate over all this n distinct value, and we will see how to calculate the first part. Like this is just a one step forward in the solution. Basically, we saw that minimum of element would be one of these elements itself, and because it is one of these elements, it would be something like nums of 2 ij, and nums of 2 ij, number of distinct value of this is order n. It is not nck or something like that, so it is order n, so it is still much lesser than what we have already, right? So let's see, let's say this is your nums2, right? And you say that okay, this is my result, like this is my nums of ij, right? Sorry, nums2 of ij. Now this is nums2 of ij. What does it mean? It means that among all chosen elements, among all chosen elements, 9 is the minimum one, right? So which all elements you would have chosen? You can choose only elements which are greater than 9, right? Because 9 is the minimum element. So you should have something which is greater than 9. So you can have 10 in this subsequence, right? Or something else as well, right? So let's take another example. Let's say 6. The value of this entire, you assume that okay, value of this entire thing is 6. So if value of this entire expression is 6, what all can be present in this expression? In this expression, 7 can be present, 10 can be present, 9 can be present, right? Because if 5 is present, the value will not be 6. The output of this expression will not be 6, instead it will be 5. So what the value would, like one of these 7, 10, 9, 6 could be present in this expression, right? Now let's say just for this example, k is equals to 3, right? Now if k is 3, and we can see here there are four elements which are possible, such that the minimum can be 6, right? So we need to choose 3 elements from these 4 elements, right? Now how would you choose that? So we need to make this entire expression as maximum. So this value is now fixed, this value is equals to 6, right? So because this entire thing is equals to 6, this is the only variable, and we want to make this entire expression as greater as possible. So we will try to maximize this sum as well, right? So see, we can have 7, 9, 10 and 6. So we can have 6, right? So with 6, this is the corresponding index in nums1. With 9, this is the corresponding index, right? With 10, this is the one, and with 7, this is the one. So which three would you choose? You can say okay, I will choose 4, 3 and 1, right? Because these are the three which are the greater, which are the top 3 greatest element which we can afford. We can only afford 7, 9, 10 and 6, and we can see corresponding elements in nums1. We can see the value is greater in 4, 3, 1. So will you choose these three? The answer is no, because you want minimum as 6. You know that minimum is 6. So 6 should be there. So you can't choose, like in this particular example, it doesn't matter, but you can't choose this one. Instead, you have to choose this one, because if you choose, let's say, these 3 elements and you skip 6 itself, it means the minimum will not be 6, but you want minimum as 6. So that's where you can see we can just select, we can just select the top 2 elements, and the remaining one we already know because 6 is now fixed, right? So hope you can see some kind of pattern here. Basically, we are trying every possible elements here, and with every possible elements, we can say whatever element we choose here, the probable candidates can be anything which is greater than 6, right? So in a way, we can sort this array. We can sort this array, and because ordering matters here, because let's say you choose 6, so corresponding to 6 this is 1. So ordering matters. So whenever we sort this part, we have to correspondingly sort the above part as well, right? Now why we are sorting this array? Because we know if we choose 6, we can choose anything which is greater than 6. So we are sorting it just to make things simple, right? So let's say you sort the array. So after sorting, the array would look something like this. So we are sorting this is in from greater to smaller. So first is 10, right? Then with 10, what is the corresponding element in nums1? It is 3. So we just put 3 here as well. So notice that we are sorting both nums1 and nums2 together, because ordering does matter here. Now we sorted this element, this array, 10, 9, 7, 6, 5, right? Now this part where we have to choose the elements which are the probable candidates is simpler. We can just say, okay, if 7 is the minimum, the probable candidates can be anything before 7, which is 3 among 3, 1, and 4, right? Similarly, if 6 is the minimum, probable candidates can be anything between 3, 1, 4, 1, right? So now we have simplified the probable, like the process of choosing the probable candidates. Now what? So let's see how we can, like, what is the time complexity now in which we are able to solve this. Let's say 7 is the, we have to iterate over all these elements, right, one by one, depend, like, because we have n possible candidates here. So we will iterate over all these elements one by one. And for, let's say we are at ith element, let's say we are at here. So if we are at here, we need to find out top k elements in this range, right? Top k elements in this range. Now how much time will we require to find the top k elements? If we try in brute force manner, we will just sort this particular part and take the top k. So sorting this particular part would require order n log n, right? And taking top k would require order k time. So order n log n plus k is the time we require to find out what is the best possible value of the left side of the expression, and right side of the expression we already fixed as 7, right? So for each right side we require this much time. So how many possible value of right side are there? N possible value. So this is the time complexity final. Even this would not pass. This is like order n into k or order n square. Even this would not pass, so we need to optimize this as well. Now which of these two factors you can remove? So notice that we can't remove this factor at all, because we, our entire base is we have to iterate over all this and distinct values of right side. So this we can't remove. So we have to remove this and somehow find out a better way to calculate the top k element in a given range, right? So notice finding top k element in a given range is not that hard. So I would encourage you to pause the video right away and try to solve this particular problem again. Like, given a index, find out the top k element in its prefix. That's the problem now. Now hope you have solved it yourself. Let's look at the solution. So notice we don't need, like, we are not asked to find top k element in any random subarray. We are asked to find top k elements in a prefix, right? So whatever top k elements is there in this particular range, right, all those elements would be contributing to the next range, right? So let's say we need to find top k elements for this 314. In the next iteration we would be asked to find top k element in 3141. So whatever top k element will be there in previous would be contributing to this as well. So because of this property, we can simply say, let's just maintain top k list of top k elements, right? And let's say we have again, let's say k equals to 2, for example, now, right? So if k equals to 2, In this particular case, let's say at 7 we maintain a list 3 comma 1, or let's just start from the beginning, right? So let's say we are currently here and we need to find top k elements, and k is 2. So initially list is empty, right? So we need to find top 2 elements. So at 10 we will not get anything, at 9 we will not get anything, at 9 we will have two elements, 3 and 1. And because there are only two elements, these are the top k elements, right? Now let's say you get it 7, so you have 4 as well. Now you already have two elements. Now you have to find top k elements in this particular part, so you have one new element 4. So what you can simply do, you can simply remove 1 from your set and add back 4. Why? Because 1 was the lowest element. So whatever was the lowest element, you can just simply replace it with something which is greater than that, right? So you just replace that lowest element with the current element, right? Similarly, let's say you get it to 6. So at 6 you get 1, right? Now at 1, what is the lowest element among this? 3. But 1 is less than 3, so it doesn't make sense to include 1 here. So 3 and 4 is the top k elements. Similarly, let's say you go at 5, you get 2. So again, smallest element here is 3, and 2 is smaller than that. So we can't, we will, if we replace one of these element with 2, uh, it will be a trade of loss. So that's where we will just keep 3 and 4. So hope this point makes sense. What we are doing is we keep on maintaining a list of top k elements, and as and when we are getting one new element, we are just taking the element with the lowest element in the set. If the lowest element in the set is actually smaller than the current element, we will remove the lowest element and add back this current element, right? So with every increment, what is the operation we are doing? We are trying to find out the lowest element in this given set, and then we are removing one element from here and adding back one more element here, right? So we need a data structure that can add an element, remove the top, like the list element, and insert and give us the least element. So add a new element, remove the list element, and give us the list element, or the smallest element. So these three are the property of heap. So we can just simply maintain a heap of top k elements here and be done with it. So this entire thing would be replaced with order log n, and hence the complexity would become order n log n, and that would surely pass, right? So just to reiterate how we solve this, we started with the brute force solution NCK. We looked at this NCK itself is not possible in the entire approach because that itself is a huge factor. So we have to remove that NCK. Now, to remove that NCK, we kind of get that, okay, if we are removing NCK, so consequence is after removing NCK, we need to not, we are saying that we will not iterate over all the subarrays or all the subsequences. And because we are not iterating over all the subsequences, still we need to find out the least score or the greatest score. So we started looking for an optimization or an observation. So here there are two operations, addition and minimum. Addition is not very much helpful here. We saw that, okay, minimum is a interesting operation because the value of this entire expression would be one of the values of nums2. And how many distinct values of nums2 are possible? Only n. So let's just take this as a starting point, and we will see, okay, given a particular value of this expression, the right side of the expression, can we determine the value of left hand side of expression efficiently? So that's where we got to know that, okay, if if we are taking a value x as the value of this right side expression, we can take anything which is greater than x. So we sorted the array, and we keep we maintain the order of nums1 and nums2 as well because the order here matters, right? Now after sorting, we saw that, okay, if we are taking an element I, we can take anything in the prefix of nums1. And what we want is we want to maximize the entire expression, and to maximize the entire expression, as the right side is fixed, only thing we can do is to maximize the left side. And that's where we say, okay, we need to find out the top k elements in the given prefix, and for that we used priority queue. So I would strongly encourage you to pause the video right away and code the solution yourself, because this that way you will be able to understand this much more, and in future you would be able to think about this kind of approach as well by yourself if it comes, right? So I would encourage you to pause the video right away and code the solution yourself. Next, I will be showing the code. Again, there is a small follow up to this problem as well, which I will give you an exercise for solve. We can discuss that at the end of the video, so stay tuned. Now, this is the solution. The solution is pretty simple. Like, we have a select best k function, which is selecting the best k or the result after sorting of the array. So this, if you give this function these two array, it will return you the answer. So that's what select best k is doing. Now, first we need to prepare these two array as well. So for how you prepare this array, we sort this particular second array, and we maintain the order of first as well. So what I have done, I have maintain the indices of nums2 as well. So I prepared a ordered nums2 vector which has nothing but the value as well as the indexes. Now I sorted this array and reversed it because I want from greatest to smallest, right? Now after reversing, we have this array, the second array in this format, and we also have the indexes as well for each of these element. Now let's say this was at index 2. So what will come here? Whatever was at index 2 in nums1 would come at index 0, right? So that's what we are doing. We are saying that, okay, whatever was at this particular index of nums1 would be would be at this the jth index of the sorted array or the ordered array, right? So after doing this, we have ordered nums1 and ordered nums2. So I just extracted, like, if you remember, ordered nums2 is a pair, right? So I extracted the first element from ordered nums2. So finally we have these two array. This is these two array with us. We pass it to select best k and return that as an answer. So now let's look at what select best k is doing. So this is exactly similar to what we discussed. We just fill up with the top k minus 1 elements first, because we want top k, right? So we fill up with top k minus 1 elements first. And after that, for every other indexes, we know that we will have k elements. So up till k minus 1, we will not have k element at all. We want to select k indices, right? So up to k minus 1, there is no way to select k indices per se, right? So that's where we just iterated over up to k minus 1 indices and just push that into our queue, and also maintain the sum because we want the sum as well. Now after that, this is what the value if I choose k minus 1th index. Now if I choose k minus 1th index, this is the minimum nums2 of j, right? And what is the sum? Sum would be top k minus 1, which is maintained here, right? And the kth element would be this nums1, right? So you notice that if you are at this index, or if you are finding the answer for this index, 4 should be present, because you can't skip 7. So 7 should be present, and because 7 is present, 4 would be present. Now you have fixed one element already. So what you want is top k minus 1 elements from the remaining prefix. So the top k minus 1 elements of the remaining prefix is this sum, and we are just taking the current element. So this is the value of the value of the expression if we choose the k minus 1th or the jth element as the right side, right? Now after that, I push this element in our queue, and also added it to the sum. And if size is k, which means that there are k elements in the queue, but we want only k minus 1, right? So if size is k, we want to remove one. So what will you remove? We will just remove the least element. So we just find out the least element, remove it from the sum, and remove it from the queue, right? So after this entire iteration, we would have explored all the indices of nums2 and find out the values of, or find out the scores for each of them, and we are already taking maximum, so result would contain the required result that we want. So hope this entire solution makes sense. If you have any doubts in this problem, please post them in the comment section below. I would be happy to answer. Now, as discussed, there is a small follow-up that I would like you to try yourself. So assume that you are solving same problem, exact same problem, but instead of subsequence, you need to find the solution of same problem with sub array, right? I would strongly encourage you to do that again because this would actually give you understanding of how to solve this kind of problems in future. So if you are not able to solve this in this particular contest, this might be a very good follow-up, and you will actually learn a lot of things by doing this. We can discuss the video. We can discuss the solution of this particular follow-up in the comment section below, and I can record a video as well if you want. So with that, hope you like the video. If you like the video, give it a thumbs up and do subscribe if you haven't already. And I will see you in the next one. Thank you.